So how can we represent a logistic regression by using a neuron model? So logistic regression is a plane separating data points belonging to two classes. Let us say we have these data points which belong to a positive class and these data points which belongs to negative class. Now this logistic regression is a plane separating these data points belonging to two classes. So let's say W is the vector perpendicular to this plane. Now I can write the equation of the logistic regression like this: sigmoid of W transpose X plus B. So this W is a vector which we can write like this: W1, W2 up to Wn, and this X is a single data point with n features: X1, X2 up to Xn. Now I can write the same equation like this: sigmoid, this term W transpose X I can write like this. This is basically summing the product of weights and this X's, Wi Xi plus B. I just wrote this term like this. So that is how we can write the equation of a logistic regression. Now let us see how can we represent this logistic regression by using a neuron. A neuron has these n inputs: X1 with weight W1, X2 with weight W2, likewise Xn with weight Wn. So this neuron does the sum here, and on that sum we apply a function which is called as activation function, and this function will produce the output of a neuron. Now if I write the output function which will look like this: O is equal to output, we are applying this function on this sum over I is equal to 1 to n Wi Xi. So that is the output function of a neuron. Now if we compare the output function of a neuron with logistic regression, which is like this: sigmoid I is equal to 1 to n Wi Xi plus B. So these two terms, this term and this term, look very similar. In fact, this term is exactly same as this term. In this output function of a neuron we don't have this B. So in order to get this B, just give input as 1 with weight as B. Now if I write the output of this neuron, it will be exactly similar to this term here. So I just the output of a neuron will look like this: summation over I is equal to 1 to n Wi Xi plus this B. Now B into 1 is B. Now the logistic regression and the output of a neuron are exactly same except this F, right? If this F is sigmoid, then this is nothing but the logistic regression. This is nothing but the logistic regression if this F is sigmoid. That is how we can represent the logistic regression by using a neuron model. Now let us see what is a perceptron, right? So this perceptron is a simplest neuron model. Let's say this is the neuron model, again with n inputs. And this is 1 and B. So sum here and F, this output, right? So output is equal to function applied over sum from I is equal to 1 to n Xi W transpose Wi Xi plus B. This is the output of a neuron. So this output, in case of perceptron, this output is either 1 or 0. the output will be 1 when this term here will be greater than 0, right? When this term here is greater than 0, right? That means if W transpose X plus B is greater than 0, when this term is positive, this term I can write like this, right? This term I can write like this. So when this term is greater than 0, the output will be 1. The output will be 0 in other cases. So this perceptron is the simplest neuron model with output either 1 or 0. So we will see how to train this neuron model by using the algorithms like stochastic gradient descent in the next videos or coming videos.